Hello everyone, welcome to my chemistry channel BL the Short and Sweet in Chemistry. Now I am going to explain the chapter Numerical Application, that in Chemical Kinetics. It is part 2, Introduction part 2, where I am going to explain first order reaction. What is meant by first order reaction? What are the concepts based in first order reaction and what are the formula here present? If you know the formula and the concept of first reaction, and it is easy to do the problems, to solve the problems. So it is the first order reaction. In first product, that is part 1 introduction, here we know what is rate law for now first order. Rate of reaction is proportional to AR to the power 1. Then if you take a constant, rate constant, then rate equal to K and molar concentration R and the power 1. 1 mean first order. If I will put 0, then 0 order. So here rate equal to minus D molar concentration R by dt. This is from that is increasing concentration and decreasing concentration for reactants and increasing concentration for product, but rate law only related with the reactants. That is why you say this is the rate where minus D R by dt molar concentration of R. Similarly, from rate law, rate equal to K R to the power 1. When both the rate becomes equal, and this is the equation. And here do one thing, dt becomes come to the left side, and here right side minus K dt. So, sorry, here not dt, it should be R, because from right side you will take R from to left side. So here what happened? dr by R, because here you will take what? Integration. That is why you will put here like this. So when you will take integration in both sides, then what happened? On integrating both sides, you see dr by R and here K dt. So what in doing integration, what happened? And here ln R mean you should put molar concentration and minus Kt plus I. I is a constant, that is called integration constant. Are you clear? You read in 12th class integration. Here in mathematics, here you can say integration of dr by R equal to minus integration of K dt. Then what is the value? ln R. Always put molar concentration R minus Kt plus I, where I is called integration constant. When T equal to 0, R equal to, that means the reaction is going to start, it is not started, then it is time equal to 0. So then what is the concentration? That should be R molar concentration 0. This indicates that this is called initial concentration. What is this one? Initial concentration means the reaction is not started. So at the time full concentration of reactant is present, so this is called initial concentration. If you put this value and T equal to 0, then put the value here. Here you put T equal to 0, then what happened? This is the answer, that I equal to ln R molar concentration 0. That means initial concentration. You have calculated the value of I. Why? What is I? I mean ln R 0. So if you put the equation in this equation, if you put the value, then what happened? ln, this is the equation. Here suppose it is equation 1. In you put equation 1 the value, then what happened? This here, instead of I, you write ln R 0. So are you clear? Then that means instead of I, you will put the value in the term of concentration. So you put the value of I here, then what happened? if you take R concentration one side, then what is the calculation? Then you put ln R molar concentration divided by R0 molar concentration equal to minus kT. If you see, if you remove this minus sign, what to do? This R0 value to go to up and R comes to down. So now what is the value here? KT equal to ln R0 by R. R0 means molar concentration of R0, that is initial concentration, and R means final concentration. So that means you want to remove this minus sign, you should change R to R0. So this is called initial value, and that one is called final value, final concentration, initial. So what is the that means formula for the first order equation? KT equal to here ln R0 by R. I hope it is clear to you. Then you will see how can simplify this one. So you take K equal to I told KT equal to 2.303. Here if you ln instead of ln, if you put 2.303 log, that is also correct. So in next equation, what to do? You will put here K equal to 2.303 by T, and here instead of ln you will put 2. So are you clear? So K equal to 2.303 T log R0 R. This is very simple form of equation, that is for first order reaction. Initial concentration, if you take R0, that is in mathematical value, suppose you put A, and final concentration R, that is A minus X. So this is initial, final. So what to do? You should write this one as 2.303 log A by A minus X. So here this is the for first order. For the second order, you only remember, not required to any derivation. So here equal to K equal to 1 by T X A by A into A minus X. So you put the value of R equal to A minus X and R0 equal to A. So this is the formula. That is not so important in 12th class. Anyhow, you should remember for different competitive exam. So next you see what are the examples of the first order. You should remember here there is no rule and regulation how to remember. So N2O5 gas changes to NO2 and plus half O2. NS4NO2, that means ammonium nitrate, and gives N2 plus 2H2O. And here, since it is first order, that is why what is the rate? Rate equal to K. Here molar concentration N2O5. And second one, rate equal to K, molar concentration NS4NO2. Similarly, third, where hydrogen peroxide in presence of iodide ion, it gives H2O plus half O2. Here also you will see rate equal to K, molar concentration H2O2. Here these are the examples of the first order. Then how we will explain by the help of graph, that is first order equation. So you see, when a graph is plotted between log R, so here you can say, here the equation you should write, how we will draw that one. If you will log R versus time at different intervals of time, so if you put log R in y-axis and time in x-axis, and for different time interval, you will get a first order, that is straight line for first order. See here, log R, see log R, here what to do? That is in x-axis, here this is x-axis, and here time is in, sorry, this is y-axis, sorry, and this is x-axis. So are you clear? Time always put in x-axis and here log are put in y-axis. What you will get here? You will get log r0, that is as intercept. As intercept. This is the formula y equal to mx plus c. C mean intercept, that is log r0, and here m mean slope, that is k equal to minus slope, and y mean log r. So from this rate constant can be calculated as a slope. K mean minus slope. So one can write similarly, if two values are 0 and r you will use, then what is the equation? See here, before example I told here k equal to 2.303 by t log r0 by r. See equation number 2. Here this is the equation where you will see equation number, and before that also you can see log ln r. Ln r, that means if you remove that means ln, you will put 2.303 log. So you can find here, you will put k equal to 2.303 by t log r0 by r. So what to do? Here graph you will draw between log r and t. Clear now? So here you will get a straight line for different interval of time, and from this also one can calculate rate constant, or one can write the equation in the form log r0 by r equal to kt by 2.0303, or you can put k1. What is k1? K1 mean first order constant. K1 mean first order constant. If you will put here only simply k, that indicates rate constant. You will put here, if you will put here k1, then it is first order. So here the plot, that is it is actually y-axis versus time, then what is the slope? Slope equal to this one. See, this is your x-axis, sorry, this is your y-axis, and t your what axis? X-axis. Then you will get slope k1 by 2.303 having minus sign. So here you see the graph. In graph, see here, log r0 molar concentration divided by r molar concentration, you will get a straight line, and slope equal to minus k 2.303. And here you are not getting any intercept, but when you take a log r, simply log r, then you are getting log r in, that is in y-axis, and t in x-axis. You are getting a straight line, but not crushing that origin, that is here having intercept of log r0. So this is the first axis formula and concept you should remember. Then integrated rate equation for second and third, though it is not so important, you should know. If you like, you should know, or if you face difficulty, don't remember. That is, it is your choice. And this is k2 equal to 1 by t, and that is x by a minus x. What is x? That means this is used. What is a minus x? That is left behind concentration of reactant, and x is the concentration of the reactant. Here you will not put any molar concentration sign because it is a mathematical value. So here when both the reactants are same, remember the reactants should be same, that means the R to the power 2 times. So here the R here same reactant, and third order also you will remember this formula where it is called K3, and what is rate? Rate equal to K3 R to the power 3. This is for second order and third order reaction. And then come to conclusion. What is conclusion of first order reaction? Radioactive disintegration, though before it was in syllabus as a nuclear chemistry, but now it is only simple knowledge you should acquire. Radioactive disintegration poses first order kinetics. That means here process always proceeding in first order kinetics. Unit of rate constant for the first order K equal to S minus second inverse. This thing all unit of rate constant you will learn in advanced video. Integrated rate equation for the first order reaction K equal to 2.303 by T log A by A minus X. The A divided by A minus X. Again see K equal to 2.303 by T log A by divided that by A minus X. This is the first order reaction. So I hope it is clear for the first order. In coming video we will see half-life period, or we may, and also we will see for gas phase reaction, and for different type volume based and different type optical rotation based first order reaction. Thanks for watching my video, and thanks again to all. I am Mrs. B.L. Das, ex-PGT Chemistry, Kendriya Vidyalaya, Sangathan. Thanks again to all.